brilliant minds! Welcome to today's exciting number theory lesson. We're going to explore the fascinating world of perfect numbers and their close relatives, deficient and abundant numbers. Let's start with a quick warm-up to get our brains ready. Think about the number 6. Can you list all of its positive divisors? Take 10 seconds to do it now. Great! The divisors of 6 are 1, 2, 3, and 6. Now, let's calculate the sum of all these divisors. 1 plus 2 plus 3 plus 6 is equal to 12. Notice something interesting? If we multiply 6 by 2, we also get 12. This means that the sum of all divisors of 6 is equal when we multiply 6 by 2. When this happens, the number is called a perfect number. A perfect number is a number perfectly balanced with the sum of all its divisors being twice the number itself. Mathematically, a perfect number n satisfies the formula. Sigma n is equal to 2n, where sigma n is the sum of all positive divisors of n, including n itself. For example, for 28, first, we need to list all of its positive divisors. What are the positive divisors of 28? Very good! Positive divisors are sigma 28 is equal to 1 plus 2 plus 4 plus 7 plus 14 plus 28. Next, we add them together. What would be the sum? Good job! The sum of its positive divisors is 56. Now, to determine if the number is perfect, we multiply the number by 2. If the product equals the sum of its positive divisors, the number is perfect. 2 times 28 is equal 56, and 56 is equal to 28 plus 14 plus 7 plus 4 plus 2 plus 1. Therefore, 28 is a perfect number. Now, if the number is not a perfect number, it can be classified as either deficient or abundant. Deficient when sigma n is less than 2 times n. This means that the sum of divisors is less than twice the number. For example, 10 has a divisors of 1, 2, 5, and 10, and their sum is sigma 10 is equal to 1 plus 2 plus 5 plus 10 is equal to 18. But 2 times 10 is equal to 20, so sigma n is less than 2 times 10, so 10 is a deficient number. On the other hand, the number can be abundant when sigma n is greater than 2 times n. This means that the sum of divisors exceeds twice the number. For example, 12 has divisors of 1, 2, 3, 4, 6, and 12. Sigma 12 is equal to 1 plus 2 plus 3 plus 4 plus 6 plus 12 is equal to 28. Since 2 times 12 is equal to 24 and 28 is greater than 24, 12 is an abundant number. Now, it's your turn. Identify whether each of the following numbers is perfect, deficient, or abundant by calculating the sum of their positive divisors and comparing it to twice the number. These are the numbers. Pause the video now to try it. Here are the answers. Are all your answers correct? If yes, then good, and you understood our lesson immediately. But if not, you can go back and watch our lesson again. Now that you understand the perfect, deficient, and abundant numbers, let's move on to the real-world application. This is the example. A city planner is designing a system to allocate resources such as water, electricity, and waste management services to different districts. Each district is assigned a numeric value representing its resource demand weight. For efficient and sustainable planning, the planner classifies these weights as perfect, deficient, or abundant numbers. This classification helps in understanding whether the resource demand is balanced and sufficient or excessive relative to the district's capacity. Your task: analyze the following district resource weights: 12, 30, 22, 496, and 7. First, you have to calculate the sum of all positive divisors, including the number itself for each weight. And the second one, you have to determine whether each number is perfect, deficient, or abundant number. For step 1, calculate divisor sums. For 12, the divisors are 1, 2, 3, 4, 6, and 12. For 30, the divisors are 1, 2, 3, 5, 6, 10, 15, and 30. For 22, the divisors are 1, 2, 11, and 22. For 496, the divisors are 1, 2, 4, 8, 16, 31, 62, 124, 248, and 496. And for 7, the divisors are 1 and 7 only. Step 2. Classification and interpretation. For number 12, sigma 12 equals 28. 2 times 12 equals 24. Since 28 is greater than 24, 12 is abundant number indicating excessive resource demand, possibly requiring additional infrastructure. For number 30, sigma 30 equals 72. 2 times 30 equals 60. Since 72 is greater than 60, 30 is also an abundant number, suggesting high resource needs needing careful planning. For number 22, sigma 22 equals 36. 2 times 22 equals 44. Since 36 is less than 44, 22 is a deficient number, potentially indicating underutilized resources or demand. For number 496, sigma 496 equals 992. 2 times 496 equals 992. Perfect balance. So 496 is a perfect number. It is an ideal resource allocation. And lastly, for number 7, sigma 7 equals 8. 2 times 7 equals 14. Since 8 is less than 14, 7 is a deficient number, means low demand, possibly allowing resource savings. Because of that, this is your time to try this next problem. Pause the video and answer. Your task is to examine these packet weights 18, 20, 15, 14, and 496. Did you classify all these numbers? If not, you can go back to our lesson. If yes, then it's good that you learned quickly from our lesson. Here's the answer. Are all your answers correct? If yes, great. Perfect, deficient, and abundant numbers beautifully show us the balance and variety in number theory. Keep exploring, questioning, and growing your math skills. Thank you for learning with me today. Keep up the great work and see you in the next lesson.